Today we're going to cover the big ideas from chapter 2, section 2 in your book. So first big idea is density curves. Density curves are always above the x-axis. And they always have an area of 1. So a density curve can look anything like you want, just above the x-axis, and the area underneath is 1. A uniform density curve looks something like this, where it is the same height, basically a rectangle. We'll start at 0 and go to k. So now if the area is 1, this distance is k, this distance will be 1 over k, because k times some number equals 1, so that number has to be 1 over k. So whenever you have a uniform density curve, whatever that distance is, this distance is 1 over that. Skewed and symmetric density curves. So those are skewed curves. This is skewed right. This is skewed left. The mean, actually the median in those is probably about there and there. So red represents the median. Now in a skewed right data set, the mean is going to be to the right of the median. So in a skewed right data set, the mean is to the right. In a skewed left data set, the mean will be to the left of the median. In a symmetric curve, the mean and the median should be very similar, if not the same. So right in the middle. The normal curve is a symmetric curve that looks something like that. Obviously, my drawing isn't quite perfect, but hopefully you get the idea. So the normal curve is perfectly symmetric. The mean is right in the center. Your book uses mu as the mean. And then if we go 1 standard deviation below, 1 standard deviation above, 2 standard deviations, 3 standard deviations, these boxes in each one of them is 34% roughly of the data. In the next set of boxes, so in between 1 standard deviation and 2 standard deviations away, there is about 13.5% of the data. And then in between 2 standard deviations and 3 standard deviations, there is about 2.35% of the data. And in the outside, so beyond 3 standard deviations, is 0.15%. So very, very little data outside. So now just a little representation here. Within 3 standard deviations, is 99.7% of the data. Falls within 3 standard deviations. Within 2 standard deviations, falls 95% of the data. Within 1 standard deviation, falls 68% of the data. So in this box here is 68% of the data. So that's just some general things about the normal curve. If you want to find the area underneath the normal curve, so you have a normal curve. Let's just say the mean is 80 and the standard deviation is 3. Oops. So that would be 83 would be your next mark. If I wanted to find the area from 70, let's just say 6 and lower, you can use table A in your book, which I'll talk about in class, but otherwise to find area on the normal curve, normal CDF on your calculator. So when you do this, it's going to be lower bound, upper bound, mean, and standard deviation. So for this one, this example, we would go to normal CDF. I'm going to make another video explaining how to do this with the calculator. Your lower bound for the area, just pick a really, really small number. So I usually do like negative 10,000. The upper bound, or cutoff for your area, is 76. The mean is 80. And the standard deviation is 3. You plug those things into your calculator, you will get out an answer. Now, the opposite way, if you're given a normal curve, let's say the mean is 72 for this one, and you're given that 83% of the data falls in between or below this point. And it's a normal curve, mean is 72. Let's say the standard deviation is 5 for this one. So to find a point along the x-axis on a normal curve, you can use table A in your book, or I recommend using your calculator. You're going to use the function inverse norm. So in there goes area to the left, mean, and standard deviation. If you type in those things, it will give you what that value is. So in this case, inverse norm, 0.83, 72, 5, and it will give you what that point is. Way to double check, it should be more than 72 if you did it right. If you want to see if data is normal, there are a couple things to do. You can graph it. So make a histogram, a dot plot, something like that. You can compare the mean and the median. The mean and median are similar, should be somewhat symmetric. You can check the 68, 95, 99.7 rule. If about 68% of the data fall within one standard deviation, about 95% of the data fall within 2 standard deviations, and 99% of the data falls within 3 standard deviations. Should be fairly close to normal. And the last thing you can check is a normal probability plot. With a normal probability plot, that's going to grab your values versus your expected z-score. What you're looking for with these is a linear pattern. So if it's linear, your normal probability plot is linear, then your data is approximately normal. If it's not linear, it's showing some other pattern, then your data is not approximately normal.